Hi everyone. Today we are going to learn groups. So before knowing groups, you have to know what is binary operation, right? What is binary operation is somewhat very important. So if the answer for binary operation, one word answer is it is also a function. It is also a function. What is binary operation means you can say it is a function. So always once you talk about binary operation group, whatever it is, always you have to consider non-empty set. In that empty set, we cannot speak anything. That's what always consider non-empty set. With the word is very important. Consider a non-empty set. Here, what I'm saying, S is a non-empty set. A binary operation star on S. Binary operation means any mathematical operation. It contains plus, minus, whatever it is. All mathematical operation here is denoted by star. The thing is how to denote binary operation star. S cross S to S. This is what binary operation. The thing is, I'll tell you an example for this. The first S, I'm going to consider a set which is like whole numbers. So 0, 1, 2, 3, etc. Okay. The first set I'm taking A. The value I'm going to assume A is equal to 1. And second set I'm going to assume the B value which is equal to 2. After that I'm going to add A plus B which is equal to 1 plus 2. The answer is 3. So that is what binary operation. What is main concept? The question also from the same set. The answer also you will get from the same set. This is called binary operation. Right? Got the idea about binary operation? Let us be a non-empty set. A binary operation star and S is a function. Star S cross S to S, this image of any ordered pair A comma B of elements of S, and a star is denoted by A star B. So you got the idea. So one S is A, another S is B, and A star, the ordered pair, you have to take ordered pair. So once you want to do many mathematical operation except negation, negative, remind everything, we need minimum of two values, right? The ordered pair we require. So A star B, which is A is also belongs to S, B is also belongs to S, this A star B is also belongs to S. So this is the concept of binary operation. Next to group. So group also you have to consider a non-empty set G, that you are considering a non-empty set, that set name is G with the binary operation. With the binary operation means it is a function. With the binary operation means it is a function. Is called group if the following axioms means the statement. Axioms are satisfied. So what are the axioms? First one is closure. It is like binary operations, right? For all A comma B the set G, right? The set is G. For all A comma B belongs to G means whatever the elements you are taking from G, each and every element you have to consider, take it from G. That's what for all A comma B belongs to G. And once you do any mathematical operation A star B, that also belongs to the same set G. That's what closure. What is associative? The same concept. You are taking three elements from the set G, and the thing is the left side we are combining B and C, the right side we are combining A and B. Anyway, you will get right side also same answer, left side also same answer. That's what it is associative. Identity means the identity element always denoted by E. There exists an identity element, E belongs to G. I'll tell you what is the concept of this symbol is denoted by there exists. This symbol is denoted by for all. So how to pronounce? This is for all, this is there exists. So what is the thing is, I'll give you some example. 5. I want with respect to addition also same answer 5. With respect to multiplication also same answer 5. What I'll do with respect to addition means I will add 0 and I'll get the same answer. With respect to multiplication means I'll multiply 1, I'll get the same answer, right? So once you will get the same value identity, then which is the identity element under addition is 0 is the identity element for under addition. 1 is the identity element under multiplication. Is it clear? So identity element always is denoted by what? E. There exists means some element which is belongs to G. So already some element is existing, that should be E. So there exists an element from the set, some element is present. That element is the identity element, right? E. So such that A star E equal to E star A equal to A, which means consider A equal to 5, the answer should be 5. That's what. So for all, where you are taking that element A, that is also belongs to G. and inverse. So inverse concept is the same concept. I want like identity element with respect to multiplication. What I'll do, 5 into, I'll multiply 1 by 5, I'll get 1, right? So with respect to multiplication, therefore inverse for with respect to multiplication is 1 by 5. With respect to addition, inverse is minus 5. With respect to addition, inverse is minus 5. You have to get whatever the thing you are doing, finally you have to get identity element. That's what this inverse. So inverse with respect to addition is negative number, and with respect to multiplication is 5 into 1 by 5. So this is what finally you have to get identity element 0, here identity element 1. So inverse. Now understood what is group. What is group? Now understood. A non-empty set G. What is group? A non-empty set G with binary operation star defined on its the following axioms are satisfied. First one, closure, associative, identity, inverse. If it satisfies all 4 axioms, it is called group. Next, you have to know semi-group. Semi means what? It is half. So, if it satisfies first 2 condition, it is called semi-group. If it satisfies first 2 condition, it is called semi-group. Next to monoid. Monoid means if it satisfies first 3 condition, it is called monoid, right? If it satisfies first 3 condition, it is called monoid. Semi means it is half, first 2 condition. Monoid means first 3 condition. Next we'll see abelian group. Abelian group is nothing. The group means 4 axioms. Group with commutative law. Group with commutative law is called abelian group. Next, ring. Ring is R plus star. This is under addition, this is under multiplication, is said to be ring. With the always binary operation plays a vital role in algebraic structure, because the binary operation is important whatever you are doing, right? So plus and star are satisfying following condition. With respect to addition, it should be abelian. Right? Abelian means commutative law. With respect to multiplication, it is a semigroup. With respect to addition, it is an abelian. With respect to multiplication, it is a semigroup with the distributive law. With the distributive law. So how to write distributive law? A star B plus C is equal to A star B plus this one. A star B plus A star C. That star may be dot, whatever it is. Okay. So this is what distributive law. Now understood what is ring? Ring means with respect to addition abelian, with respect to multiplication semigroup, with distributive law is called ring. Integral domain. Integral domain means commutative ring. Commutative ring means commutative law it should satisfy with identity element without zero divisor. Without zero divisor is called integral domain. Next, field. A commutative ring. You know, commutative ring means a ring with commutative law with identity element. Every non-zero, this is very important, every non-zero element has multiplicative inverse. For example, 5 means it should contain 1 by 5, because the multiplicative inverse for 5 is 1 by 5. Subring, the same concept of subgroup. You have to consider one set with set, and that set must be a ring. Within the subset, the subset I am taking, yes, both the things should satisfy group condition. That subset also satisfying ring condition, it is called subring. Okay. Next, ring homomorphism. Ring homomorphism is nothing but it is a function based on 2 concepts. One is here I am taking plus, here I am taking direct plus. So the left side you are using the first function, and second side you are using the second function. Similarly here also, right? So this is also direct plus. So for all where you are taking all the element from the ring. So this is the concept, basic concept. Thank you.